Today we're finishing the chapter by doing section 6.6. It's all about reasoning with special quadrilaterals. So our objective today is to identify special quadrilaterals based on limited information. So I'll give you a diagram with a few things labeled, and you have to decide what we're talking about. Is it a rhombus? Is it a rectangle? Is it a square? Is it a trapezoid? And so on. So we're going to review the features of all of those things, and then we'll start looking at problems. So it is a lot of writing at first, but then once we get into the examples, it'll go pretty quickly. So if you're trying to prove that it's a parallelogram, these are the ways you could do it.
So we gotta write this.
You got to write this down. Yep. So number one, both pairs of opposite sides are parallel. The second way to prove it is that both pairs of opposite sides are congruent. The third way you could prove something is a parallelogram is that both pairs of opposite angles are congruent. Another way is if the diagonals bisect each other, and the last way is if one pair of opposite sides is both parallel and congruent. So, lots of ways to prove it's a parallelogram. So if you've decided that something's a parallelogram, before you answer parallelogram, you should check on these other three: rhombus, rectangle, and square, since those are all types of parallelograms. So in order to be a rhombus, all four sides have to be congruent, and the diagonals are perpendicular. And then to prove something is a rectangle, you would look at the angles. So if the four angles are all right angles, or if the diagonals are congruent, those are ways to prove it's a rectangle. Now, what happens if it's a rhombus and a rectangle at the same time? We just talked about it. If it's a rhombus and a rectangle, if the four sides are congruent, the diagonals are perpendicular, the four angles are right angles, and the diagonals are congruent, what would we call it then? A square. Very good. So that's how you can prove that something is a square. So if it's a rectangle with congruent sides, or a rhombus with right angles, or if the diagonals are perpendicular and congruent. So those are the ways to prove something's a rectangle. Or no, sorry. Woo, my bad. That's the way to prove that it's a square, which is also technically a rectangle. So I wasn't too wrong there. Be careful with square. Sometimes it sneaks up on you. If you want to write rectangle or you want to write rhombus, I would just take a second to make sure that it can't be a square. Square is very specific. It has to have lots of features. So just don't be tricked. If you see that all the sides are congruent, don't instantly say rhombus. Look a little deeper. Check the angles out too. Any questions on squares? Oh, this is a typo. How did I miss that? A trapezoid is not a parallelogram. It's a quadrilateral. Typo. So fix that. So if you know you have a quadrilateral and you're trying to show that it's a trapezoid, the main thing you want to look for is that one of the sides, one pair of the sides are parallel. And then if you decide that it's a trapezoid, you should just look real quick to see if it's an isosceles trapezoid. So if you know that it's a trapezoid and you see that the legs are congruent, then it's called an isosceles trapezoid. So again, everything we're going to be given today is a quadrilateral. It's going to have 4 sides. If opposite sides are parallel, we can call it a parallelogram, or we can call it one of the special parallelograms, which would be rhombus, rectangle, or square. And then if only one of the sides is parallel, one pair of the sides, then we call it a trapezoid. So there's like 5 answers today. Trapezoid if only one pair is parallel. Parallelogram if two of the pairs of sides are parallel. And then if there's any other special features, we should look for square, rectangle, rhombus. And then if you know it's a trapezoid for sure, you might be able to say isosceles trapezoid, maybe not, just depending on the information. So today's the day where we sort of take all the sections we've been talking about this week and we put them all together. Do you guys have any questions before we look at some examples? All right, here are the first 4 examples. I'm going to give you a second to write these down. So sketch the pictures. Make sure you're labeling them exactly how they're given. You know, one little set of arrows can definitely change a lot of things, so take your time when you're drawing these. All right, let's take a look at number 1. What are your thoughts on number 1? It's definitely a trapezoid, right? Because only one pair of sides is parallel. Okay, so once we know it's a trapezoid, we could say regular old trapezoid or isosceles trapezoid. What do you think? Yeah, this one is actually an isosceles trapezoid. Whoops. The reason that it's an isosceles trapezoid is because of these right here. The legs are congruent and one pair of sides is parallel. So that's isosceles trapezoid. Good. What about number 2? I'm noticing that the opposite sides are congruent. Opposite sides congruent is what? That's just a parallelogram. Good. Now, remember, there are 3 special types of parallelograms, so you might want to just take a quick check to see if it's any of those. It can't be a rhombus because the sides aren't congruent. Can't be a rectangle because the angles aren't given. And then it definitely can't be a square because it would have to be both. So this is just a regular old parallelogram. All right, number 3, what are we thinking? I see one pair of parallel sides. One pair of parallel sides leads me to Nope, can't be a rhombus because the sides aren't all congruent. Other thoughts? If it's going to be a parallelogram, the opposite sides would have to be congruent. So that's out. If it's not a parallelogram, it's definitely not a rhombus. So rhombus is definitely out. Once you rule out parallelogram, you've also ruled out rhombus, rectangle, and squares. The only one left is a trapezoid. Yep. And it's not an isosceles trapezoid because the legs are not congruent. One's 12 and one's 13. Good. Number 4. Any thoughts? Just a parallelogram, yep. I heard someone say rectangle. What are all the measures of the angles in a rectangle? They're all 90, so it definitely can't be a rectangle. So it's kind of like a process of elimination thing. You could go through all these like, okay, it's definitely not a trapezoid because I'm not given one pair of sides as being parallel, so that one's also out. Might be a parallelogram, not a rectangle because the angles aren't right. If it's not a rectangle, it's definitely not a square. We don't know any information about the sides, so it's not a rhombus. So you can just sort of like process of elimination, narrow it down. Parallelogram's the only one that would fit. So, any questions on these first 4? All right, the next 4, I'm not going to require you to write in your notes, but I do want you to just sort of help me reason through these. So number 5, does anyone have any thoughts on number 5? It is a parallelogram, but more specifically, it's a... Yeah, this one's a square. The reason it's a square is because all of the sides are 3, right? All the sides are congruent, so it might be a rhombus, right? And then you see that all the angles are 90 degrees. If these 3 are 90, the last one has to be 90. That's the only way that I'll add to 360. So once you know that all the sides are congruent, all the angles are right angles, that's a square. Good. Same thing on number 6. If you're given that 3 of the angles are right angles, the 4th one has to be a right angle. You'd do 360 minus 90, minus 90, minus 90. You'd be left with this has to be 90. Okay? So right now we know that all 4 angles are 90 degrees. What kind of figure is that? It's a rectangle. Good. All right, number 7, we don't know anything about the angles, but we know that all the sides are 8. Your first guess was not specific enough. Your second guess was too specific. What's between a parallelogram and a square? We don't know anything about the angles. Don't say anything about the angles. So rectangle and square are out because we have no information about anything. The only thing you can do is here rhombus, yeah. Now, originally I heard someone say parallelogram. Parallelogram is not wrong by any means. You can just be more specific, okay? It's definitely a parallelogram because the sides, the opposite sides are congruent. But again, if you have parallelogram, you should check rhombus, rectangle, square just to see if you can be a little more specific. All right, and then number 8, I'm noticing that all the angles that I'm given, all the consecutive angles are supplementary. That sounds like a what? You could also notice the opposite angles are congruent. If this 100 was down here, then it'd be an isosceles trapezoid. But since they're across from each other, they're opposite angles. It's the first one we talked about. Yep, parallelogram. Good. What? Oh, I didn't hear you. I'm sorry. You gotta speak up. All right. Any other thoughts on these 4 that you want to discuss? All right. If not, I'm going to give you your homework. We're going to do the first 8 together just to get you going. And then you'll have the rest of class to finish the worksheet. All right. So on this worksheet, this is lesson 6.6 practice A worksheet. The directions say, use the information given in the figures at the right to determine if the following statements are always true. It says explain your reasoning. We're just going to explain the reasoning out loud. You don't have to write it down, so you can cross that part out. We'll just reason through it as a group. So number 1 says, in a rectangle, all the sides are congruent. Does that have to be true? Are all the sides congruent in a rectangle? It doesn't have to be true. You can't say false because it might be true, but it doesn't have to be true. So we're going to say not always true. If you had a rectangle and all the sides were congruent, then we call it a square. So it could be true, but not always true. Number 2, in a rhombus, all the sides are congruent. Is that always true? Yes. So number 2 is always true. That's the definition of being a rhombus. Number 3, in a trapezoid, the legs are congruent. Do they have to be congruent? In a regular old trapezoid? No. It could be, then we call it an isosceles trapezoid, but they don't have to be congruent. So this is not always true. Number 4, in a parallelogram, opposite sides are congruent. Does that have to be true? It does have to be true. That's always true. All right, number 5, in a parallelogram, all the angles are congruent. That's not always true. When it is true, we call it a rectangle. So in a parallelogram, they don't always have to be true. The opposite angles have to be true, but they don't all have to be congruent, but they don't all have to be congruent. Number 6, in a rhombus, all the angles are congruent. In a rhombus, that's not always true. If it is true, we call it a square. Alright, number 7, in a trapezoid, each pair of base angles is congruent. Not always true. Again, if it was an isosceles trapezoid, it would be always true, but just a regular old trapezoid, this is not always true. And then number 8, in a square, all the angles are congruent. That's always true. Good. All right, looking through this homework, 9 through 14 is exactly like what we did up on the board. You'll notice in the directions that isosceles trapezoid isn't there. You just have a trapezoid, parallelogram, rectangle, rhombus, square. The reason isosceles trapezoid isn't there is because none of them are isosceles trapezoids. So do not write isosceles trapezoid. It'll be wrong, okay, because none of these are isosceles trapezoids. And then 15 and 16, just read the directions and see if you can reason through those. Let me know if you get stuck. You have the rest of class to work on this.